Jika Anda mengklik video ini, maka Anda memiliki kesempatan istimewa belajar dari sekelompok ilmuwan tentang bagaimana pertanian di Amerika Serikat secara bertahap dan mampu mengurangi bahkan menghentikan penggunaan bahan sintetis dalam pertanian mereka. Bagaimana cara mereka bisa tetap mendapatkan hasil panen yang konsisten dengan modal yang lebih rendah dan laba bersih yang lebih tinggi. Untuk mengawali bagian pertama ini, mari bergabung bersama Dr. Rick Haney dari Temple, Texas untuk mengetahui tentang penelitiannya di wilayah ini.
Microbes are alive in the soil, and we've ignored that for a long time. Microbes take in O2 just like we do. We breathe in oxygen, and they breathe out CO2. Microbes do the same thing. The harder we work, the more CO2 we release. The harder they work, the more CO2 they release. It's a very similar thing. So back in graduate school in '94, we were looking at Alan Franzluber's was showing me this equation that he thought he developed about CO2 and soil respiration. He was doing 21, 24, 36 days incubation studies. And he thought, using some algorithms, because Alan's way smart, that he said, he brought me in, I'll never forget it, because he brought me in there and he said, I think we can do this quicker than a 3-week incubation based on this algorithm I've developed. And so I said, I'll tell you what, I'll start measuring it. I'll start doing a 1-day CO2 and a 3-day CO2.
Yep.
And we'll see if what you think is right.
Yes.
And sure enough, it was. Then we started correlating 1-day CO2 with laboratory nitrogen mineralization in 3 or 4 weeks. And we saw these phenomenal relationships.
Yes.
And we were like, that can't be. Because we were shocked that you could take a soil and dry it and re-wet it, trap the CO2, and we kept seeing that these soils that had higher CO2 were more fertile soils, because these were soils we knew.
Dalam pertanian modern ini, peran mikroorganisme sering disalahpahami, padahal peran mereka sangat penting guna menjamin tersedianya tanah yang sehat untuk budidaya pertanian. Untuk memahami hal ini, berikut ada penjelasan dari Dr. Christy Nichols dari Mandan, North Dakota.
We have this idea that microorganisms are bad. In reality, most of the organisms in the soil are beneficial.
Even nematodes?
Most of the nematodes that are in the soil are not plant pathogenic. Most of the nematodes that are in the soil are actually very good at helping with especially nitrogen cycling, because they consume a lot of bacteria, and when they consume that bacteria, part of the waste they give off is higher in nitrogen. So it actually is an important role in the system.
Yes.
When you have these levels of diversity of organisms. When an organism becomes bad, it becomes bad because its population is out of control. That diversity helps to keep populations in check. So in the soil, predator and prey relationships are very important. And every organism is either eating another organism or being eaten. There are types of fungi that actually they'll kill nematodes. And you have fungi that actually will kill microarthropods. So, even the smaller organisms are able to attack some of the larger organisms. And like I said, then that keeps the diversity in the populations in check, so that you don't get a population out of control and it doesn't become bad.
Okay.
So it's really important for us to try and work on that level of diversity. And a lot of the things that stimulate that level of diversity are the diversity in our crop rotations, or
Okay.
diversity above ground. There's a lot of research that shows that diversity above ground is sort of equated or even masked by diversity below ground. So that diversity above ground, what it does is it provides different foods for different organisms, because that organic matter, the materials that's inside the plant, have different carbon and nitrogen ratios. And because there's different carbon and nitrogen ratios, it's a different type of food. I sometimes talk about, if you do a single crop, a continuous crop, it's kind of like giving the soil the donut diet, because you're feeding it the same thing over and over and over and over again. And so the only organisms that are able to grow and repopulate are the same organisms that are feeding off of that.
Yes, yes.
Whereas when you have that diversity, there are different organisms that become players in the system.
Ketika kita melakukan pengolahan tanah, ekosistem tanah akan terganggu secara masif. Dr. Ellen Kledivko melakukan perbandingan antara ekosistem alami dengan sistem olah tanah dan apa yang terjadi jika kita mengolah tanah.
If you think about natural ecosystems, they don't have a tillage implement running through them once a year or a couple of times a year, but nutrients get recycled and trees grow or grasses grow, and what's recycling the nutrients are the organisms. And so part of what we're saying with a no-till system is that if you don't take an implement through there and you allow the system to kind of come back, that there will be organisms that will do that job for you. They do it differently, obviously, than a piece of metal would do it, but they can be very effective. And besides loosening the soil or making burrows, they do some of these other things like convert nutrients, recycle nutrients, have pathways where roots can grow, and then those pathways stay there. You don't. If you think about a tillage implement, any root channel from last year in the topsoil is going to be totally broken up by a tillage implement the next year. If you have a nightcrawler channel, or even if you have a redworm channel that's part of the redworm channel, it's there. Yes. And then the roots can follow that, and so you can have channel built upon channel built upon channel. And the nightcrawler channel, maybe a root, maybe a corn root, maybe a cover crop root will go down that, and then the next year another nightcrawler, and so on. So it builds upon itself.
Will you explain to us why organic matter decomposes faster because of tillage?
A tillage operation does a couple things. Number one is it opens up aggregates that were otherwise protected. So you're opening up more surfaces for the bacteria to decompose the organic material faster. That's probably the main reason. Sometimes people say, well, you're putting oxygen in the soil. It's not really so much that as by breaking up aggregates, you expose the organic matter in the soil to decomposition, whereas when it's in an aggregated state in the soil, some of that's protected, and the bacteria that decompose that organic matter can't get to it.
So the tillage actually favors then, say, bacteria that would live in that environment. And that's maybe what causes the flush of carbon dioxide and nitrates into the soil as well, I guess.
Oh yes. The flush of carbon dioxide is very much related to the tillage.
The tillage operation.
Right.
Okay, yeah.
Right.
Sistem pertanian menginginkan intensitas air yang ideal. Di Amerika Serikat, para petani melakukan hal ini untuk mengatasi masalah air ini. Dr. Chris Horton dari NC State University akan menjelaskan bagaimana cover crop akan mempengaruhi dinamika air.
Water, I think, is going to be a real limiting factor over the next several decades. And particularly here in the southeast, we tend to get most of our summer precipitation in these huge rain events. And one of the things that cover crops bring to this system is they slow the movement of water across our fields. And so that we think that we have a lot of yield potential that we can garner with cover crop residues by allowing more water to soak into the soil.
Okay. Well, tell us about some of the actual work that you've done.
Sure. Well, we've worked both in corn and soybeans at this point.
Yep.
So we started with soybeans, and there we use a rye cover crop. One of the ways that we're going to get more biomass into these systems is not treating the cover crop as an afterthought. Thinking of it as a key part of the production philosophy of the field. We plant our rye cover crops early, which makes a big difference. We try to plant that in October as opposed to throwing it in, November, December timeframe. That does tremendous amounts for us. It's interesting what that does for water dynamics. I think for one thing, it makes it actually drier in the spring. If you think about it, if you're going to plant a plant out there over the winter and we're going to grow it, we're going to extract water out of the soil over the season. So as you plant, we can actually be a fair bit drier than we would be. Now that can be a plus or minus depending on where you're farming. So in some areas, traditional no-till agriculture without the cover crop, we can be a bit wet and cool later into the spring, and so getting into the field can be a trouble. So some drying can be a benefit on some soil types. Okay. On some soil types, it can be a greater concern. But then at some point in the season of that soybean, then flops. The plot that had the cover crop now becomes the wetter one, because we're soaking in, again, those big rain events that come in. We're allowing greater water infiltration in those than we are in a conventional no-till setting where we don't have that residue to break up the water. Okay. Corn, of course, we stand even greater benefit. In our work with corn, we've done, again, that side-by-side comparison with and without the cover crop. And we can see that, certainly by the time we get to silking, which can be a very important time for water dynamics, those two have flopped under our conditions. So now the one with the cover crop mulch is now wetter than the one without a cover crop mulch. Both of them done via no-till. We can actually score that. We go in and we look at our corn plots and we rate when in the morning under drought conditions does the leaf first start to curl. That's a powerful integrator telling you what the water stress on that plant is. And the plants under normal no-till are rolling well before, hours before we see them rolling under no-till with a massive cover crop under there. So we think that alone right there, it gives you longer period each day to grow, to set carbohydrates, to build your yield.
Legume atau tumbuhan kacang-kacangan, tanaman inti dan cover crop merupakan bahan alami yang akan menciptakan simbiosis di dalam tanah. Ketiga kombinasi tanaman tersebut dapat memaksimalkan kinerja mikroba untuk memasukkan nitrogen ke dalam tanah. Dr. Judy Grossman dari NC State University akan menjelaskan tentang bagaimana memaksimalkan sumber daya ini.
My work really involves looking at legumes to try to figure out how we can really make them the most efficient nitrogen source we possibly can by looking at the microbial component of the legume rhizobia symbiosis. We work a lot with organic farmers simply because right now those are the farmers who are really interested in using legumes for nitrogen supply. As nitrogen prices go up, we're going to need to turn to some of these alternative processes such as nitrogen fixation. And when that happens, we need to be able to hit the ground running. We can't say, oh, okay, now we're going to start doing the research. We really want to get to know how, when you take a strain of bacteria, and you look at its DNA, how does it differ from other strains of bacteria? Okay. Because you can have some that are very high performers and they fix a lot of nitrogen, and you can have others that don't really do a heck of a lot for the plant. In my mind, what would really help the farmers is trying to understand the tools they can use as farmers to help increase nutrient supply to their crop plants. So try to figure out how much nitrogen is supplied when they put a legume in the soil and let it decompose, how that is released, when it's released, how we can get more nitrogen into the legume by enhancing the fixation ability of the microbes. So all these little pieces will help us be able to help farmers develop their own research, their own experimentation, so they don't need to rely on the recipes. They can say, oh, I know that if I can calculate a square meter of legume biomass, and I can calculate how much I have and how much nitrogen is in that square, I can then figure out on my whole field how much nitrogen is being added through this legume to my soil. And so those are the kinds of things I really want to give to farmers in terms of having them understand how they can control their biological processes in their field on their own and not have to rely on recipes.
Sebelum kita mengakhiri pembahasan kali ini, ada satu hal penting yang perlu kita renungkan bersama. Selama puluhan tahun, banyak petani di seluruh dunia diajarkan bahwa solusi utama untuk meningkatkan hasil panen adalah menambah input. Ketika tanaman kurang subur, tambahkan pupuk. Ketika muncul penyakit, tambahkan pestisida. Ketika tanah mulai keras, olah lebih dalam. Namun seiring berjalannya waktu, banyak lahan justru menjadi semakin bergantung pada input yang semakin mahal. Namun di sisi lain, para peneliti dan petani regeneratif di Amerika Serikat mulai melihat masalah dari sudut pandang yang berbeda. Mereka tidak hanya bertanya, apa yang dibutuhkan tanaman, tetapi juga bertanya, apa yang dibutuhkan tanah. Karena pada akhirnya tanaman yang sehat lahir dari tanah yang sehat. Dari pembahasan hari ini, kita belajar bahwa cover crops bukan sekedar tanaman pengganggu yang memenuhi lahan kosong. Mereka adalah pelindung tanah, penghasil bahan organik, dan sumber makanan bagi mikroorganisme. Kita juga belajar bahwa legume bukan hanya tanaman penutup tanah biasa. Dengan bantuan bakteri penambat nitrogen, mereka mampu mengambil nitrogen yang melimpah di udara dan mengubahnya menjadi nutrisi yang dapat dimanfaatkan tanaman. Dan yang paling menakjubkan, kita melihat bagaimana dunia mikroba yang tidak terlihat oleh mata ternyata memegang peran besar dalam menentukan kesuburan tanah. Miliaran mikroorganisme bekerja setiap hari tanpa upah, tanpa istirahat, mengurai bahan organik, menyediakan unsur hara, memperbaiki struktur tanah, dan membantu tanaman menghadapi berbagai tekanan lingkungan. Alam sebenarnya telah menciptakan sistem pertanian yang luar biasa efisien. Tugas kita bukan melawan sistem tersebut, melainkan memahaminya dan bekerja bersama dengannya. Inilah pelajaran besar yang bisa kita ambil dari Ilmu Pertanian Amerika Serikat. Semakin kita memahami biologi tanah, semakin sedikit kita harus bergantung pada input yang mahal. Semakin hidup tanah kita, semakin kuat tanaman kita. Dan semakin kuat tanaman kita, semakin besar peluang kita untuk membangun pertanian yang produktif, menguntungkan, dan berkelanjutan untuk generasi berikutnya. Jika Anda seorang petani, cobalah mulai mengamati tanah Anda dengan cara yang berbeda. Jangan hanya melihat tanaman yang tumbuh di atas permukaannya, tetapi pikirkan juga kehidupan yang bekerja di bawahnya. Karena rahasia kesuburan seringkali tidak terlihat oleh mata, tetapi dampaknya bisa dirasakan pada setiap musim panen. Terima kasih sudah mengikuti pembahasan ini sampai akhir. Jika Anda mendapatkan manfaat dari materi ini, jangan lupa untuk membagikannya kepada petani lain agar semakin banyak orang memahami pentingnya membangun kesuburan tanah secara alami. Tulis di kolom komentar pengalaman apa yang pernah Anda rasakan saat menggunakan cover crops, tanaman legume, mycorrhiza, atau metode pertanian biologis lainnya. Saya sangat tertarik mendengar cerita Anda dan pengalaman dari lapangan. Jangan lupa klik tombol like, subscribe, dan aktifkan lonceng notifikasi agar tidak ketinggalan seri berikutnya. Karena di bagian kedua nanti, kita akan membahas topik yang tidak kalah menarik. Bagaimana petani-petani Amerika menggabungkan cover crops, mycorrhiza, kompos, dan sistem no-till untuk membangun tanah yang semakin subur dari tahun ke tahun, bahkan saat penggunaan pupuk kimia terus dikurangi. Sampai jumpa di video berikutnya. Tetap semangat belajar, tetap mencintai tanah, dan ingatlah bahwa masa depan pertanian tidak hanya ditentukan oleh apa yang kita berikan kepada tanaman, tetapi juga oleh bagaimana kita merawat kehidupan yang ada di dalam tanah. Selamat bertani dan sampai jumpa di video berikutnya. Salam Urban Farming Indonesia.